algebra is the study of sets and how those sets interact with one another. What is a set? That would be important to know. A set can be anything. Specifically, when we're in Algebra 1 and 2, we talk about sets of numbers. But it doesn't have to be numbers. When you get into higher level algebra, like when you're working on your master's or your PhD or group theory, then you would be talking about arbitrary sets. It could be a set of sofas or a set of forks or anything. But in Algebra 1 and 2, we'll stick with numbers. So we have different sets of numbers that we like to talk about. And I have 6 listed for you. Okay, the natural numbers is a specific set of numbers: whole, integers, rational, irrational, and real. So first of all, what are the natural numbers? They're just the counting numbers. Okay, so for example, 1. Here, let me choose a different color. 1, 2, 3. The numbers that you would use to count things. Okay, starting with 1 and going up from there. The whole numbers are the natural numbers, but they also include 0. So 0, 1, 2, 3, and going up from there. Okay. And the integers are like the natural numbers and the whole numbers, but they also include the negatives. So, for example, -2, -1, 0, 1, 2, etc. Okay, going on forever in both directions, the positive direction and the negative direction. Okay. Before we get too much further, let's continue with the natural numbers, the whole numbers, the integers. This is just a side note. You don't necessarily have to know these symbols. But mathematicians like to shorthand things. You've heard people say that mathematicians are lazy, and sometimes it's kind of true. So instead of writing out the natural numbers, we like to shorthand things. So we use symbols, and the symbol for the natural numbers is a blackboard bold N. And a blackboard bold N is just an N with an extra line in front. So an N like this, and then we put an extra line in front. Blackboard bold, and that's a symbol for the natural numbers. There isn't a symbol for the whole numbers, but there is one for the integers. And for the integers, we use a blackboard bold Z, which similarly is just a Z with an extra line in it. Okay, so blackboard bold Z. Okay, let's keep going. The rational numbers. This is where it gets a little bit less clear, but the rational numbers are all of the numbers on the number line that can be written as a fraction. Okay, but it doesn't have to be a fraction. It's just a number that can be written as a fraction. So for example, 5 is a rational number because 5 can be written as 5 over 1. And let's say -6.2. -6.2 can be written as a fraction of integers. -62 over 100, right? Over 10, sorry. -6.2. So terminating decimals, okay? All of the natural numbers, all of the whole numbers, all the integers are all rational. The terminating decimals are also rational numbers, okay? Normal fractions that you would think of, like 2/9, okay, definitely rational. And repeating decimals are also rational. So 8.31 repeating, and the 3/1 repeats, that can be written as a fraction. So that is a rational number. So then, what's irrational? Irrational are all the numbers that are on the number line that cannot be written as a fraction. So these are decimals that do not ever end and that do not ever repeat. So non-repeating, non-terminating decimals are irrational. Can't be written as a fraction. So for example, let's say you have 4.3 3, 7, 1, 2, 9, 6, 1, 2, 4, 3, 4. Okay, and it just keeps going, and it never repeats and never ends. This would be a irrational number. Some common examples of irrational numbers, you've heard of pi, okay, you use that. It's a decimal that doesn't ever end, doesn't ever repeat. That's pi is a common example. E is another one. You may not have heard of it yet. We use it in business and in physics a lot. Okay, so this E in calculus, it pops up everywhere. Another very common example of an irrational number is the square root of a prime number. Okay, so roots of prime numbers are almost always going to be irrational. Okay, and then what are the reals? The reals are the whole number line. Whole might be confusing. Let me say entire number line. Everything on the number line is a real number. Okay, good. So let's go back to our symbols. Okay, just remember this is just FYI. Don't necessarily have to know this. The symbol for rational numbers doesn't make sense. It's a Q. It's a blackboard bold Q for rationals. And I guess I had to choose something because R was already taken. R is the symbol for the reals. Okay. There is no symbol for whole number and there's no symbol for irrational. And we have these blackboard bold symbols just in case you want to shorthand your work. Let's look at some examples, or we're going to look at number 2. I think that's the only one we'll do today. All right. Oh, I forgot. I want to show you one example real quick in the textbook. Textbook's handy help if you ever need it. Okay, on page 48. This is just a good visual representation of the numbers. So remember we did the natural numbers first. There's a very small set of numbers. Then the whole numbers include the natural numbers, but you add 0. Okay, so think of the natural numbers as a small set. The whole numbers include the natural numbers, but it's bigger. Okay, integers. Every whole number is an integer, but integers include the negatives. Okay, every integer, every whole number, every natural number is a rational number. And a rational number means a number that can be written as a fraction. We have some terminating decimals, some repeating decimals, we have some mixed numbers, all rational. Okay. Now, if it's not rational, then it's irrational. Okay. Irrational, things like square roots of prime numbers, square roots of numbers like 15 is 3 times 5. There's no doubles. It's just 3 is a prime, 5 is a prime, so 15. Square root of 15 is going to be irrational. Pi is an irrational, anything that has pi in it. Now, if you take all the rationals and all the irrationals and put them together, you get the real numbers, the whole number line. All right, great. So, close this. Let's look at number 2. We want to list all the numbers from the given sets that are natural numbers, whole numbers, integers, rationals, irrationals, and reals. So let's start with natural numbers. Okay. So for the natural numbers, I'm just going to do this with highlighter. We'll just talk about it. The natural numbers are going to be counting numbers not including 0. So 10 is the only one in this list. Okay. So yeah, let me highlight it like this. 10. The rest of these, they have decimals or 0, not a natural number. All right, great. What about the whole numbers? Whole numbers are going to be natural numbers, so all the natural numbers, and 0. All right, great. What about the integers? The integers include all of the natural numbers and the whole numbers, and it includes the negatives. So here's a negative. Okay. What about the rational numbers? Rational numbers include all of the natural numbers and all of the whole numbers and all of the integers and numbers that can be written as fractions and numbers mixed numbers that can be written as fractions, and terminating decimals or repeating decimals. Okay, so we have all the rationals. What about irrationals? Irrationals are going to be everything that wasn't rational. Okay, so we had, these were all rational, so the only two left are going to be the irrationals. What about real numbers? Real numbers are everything on the number line. Okay, so all of these. Good job.